In this lesson, we're going to be building this sort of an effect here, where we get to do have the best of both worlds, like a pose morph type thing, or a morphing object that acts as a suction target for a fluid sim to help keep these fluids suspended in air while still behaving like liquids and stuff like that. You can generally use whatever font you would want or even other shapes, but we're just going to be doing something simple just to get the point across. I think this is a really cool way. It's like my favorite way to like mess around with fluids right now. I think it just kind of creates some really interesting abstract shapes and just gives you a lot of control over fluid sims, which are really, really cool looking in the end, I think. So over here in Houdini, I'm going to just set up my quad layout. I've done this before in previous chapters and at the intro lesson to the second part of the tutorial series, but I'm just going to do it again one more time here. So we're going to hold down Alt and click on this little bar in the middle of our network, and this is starting from the build layout, by the way. I'm going to go and option click here in this bar in the middle so that this splits, this kind of pivots it left and right. I'm going to go up here and say split pane top bottom, and go up here and say split pane top bottom. Then down here, I'm going to right click, choose the network view, and then up here, I'm going to right click and choose the parameter view. Then I'm going to deal with my push pins here. Right click and choose pin 1, pin 1, pin 2, and pin 2. And then over here, I'm going to just split this pane top and bottom. Down here, I'm going to, let's just start that one more time. I'm going to say split pane top bottom. I'm going to right click here and choose the geometry spreadsheet. And I'm going to also add an animation editor because we're going to be doing some keyframing stuff down here as well. Let's leave it on this geometry spreadsheet for right now and just drag it down as far as I can. And we should be good to go. So let's start off this whole thing by throwing down a font. I'm going to throw down a new geometry node. And I'm going to call this our target. And in here, we'll throw down a font. And by default, the font, I'm going to just hit the D key and change my background to be the right color. Just dark on the background, and I'll just remove my origin nomen. So by default, this font is actually displaying the frame that we're currently on, which is kind of cool. You can use a little expression in there to do that. I'm going to just put down the word liquid like we had in the example, and hit Control Enter, and that becomes liquid like so. You could choose any font you want. I find that a nice kind of like thick one like this works pretty good. I'm going to actually choose to use, let's see if there's, Helvetica Bold, I think was the one that I used in my example. So I'll go with something like that. As long as you're in the ballpark, we should be good. The next thing I'm going to do is just apply a little bit of extrusion to it so that it has some thickness. So I'm going to throw down a poly extrude. And just wire that in here, and we'll just give it a distance of about negative, let's say 3.5. Oh, sorry, point. Escape. Okay, 0.35. And by default, the poly extrude is not adding haps. We're just going to tick this output back button here so that it actually fully encloses the word liquid. And then I'm just going to throw down another transform node so that it centers this liquid about the z-axis, because right now it's just extruding it inward. I just want to center it once again, so throw down a transform. Wire that here, and then we'll just translate it in z by the negative centroid of the incoming geometry. So that's going to be negative centroid of the 0 geometry, which is the first input coming in right here. signified by that 0, and then DZ. So it just looks at whatever that is and brings it in centered. So now if I were to go back up here and change this extrusion distance, it's actually extruding it and keeping it kind of centered, as opposed to just extruding it back in Z-space. So I'm going to just put it back to 0.35 and go to our transform here. And I think that at this point, I'll just say that this is, I'm just going to put down a null. And note that this is going to be object A. Because then we're going to create an object B over here, and then we're going to do some interesting stuff with particles. Not really a particle sim per se, but just like a SOPs level particle transition that we'll use to drive our targets. So this is going to be object A, and let's just quickly make a flip sim out of this real quick, so that we can just show what how easy it is to first set up the initial suction force before we get into really tweaking it and getting it looking nice. So over here, I'm going to just go up to, let's go and create a flip fluid from object. We're going to use this target to create a flip fluid. So we'll say flip fluid from object. And that throws down our nodes here. I'm just going to grab them all, hit, hold down A and drag down to align them. So that creates our auto dot network, and then our target fluid and fluid interior. This is what I like to call the fluid export, and then the fluid interior if we want it. We actually aren't going to need it for this example, so I'm just going to delete it. It's just not going to be necessary. So here on the auto dot network, let's just jump in there, and we've got our flip fluid object. It's pretty low res, but if I hit play, the word liquid starts falling down under the force of gravity. I'm just going to decrease the particle separation to increase the resolution of these particles on our fluid. So let's go to 0.05 for right now. And really you can kind of see the form liquid start to take shape. I'm going to just maybe bring it down a little bit further, maybe 0.01. That's pretty high res, so let's just play that back and see how it's doing. I mean, it's keeping up a little bit. Maybe I'll just go a value of 0.02 and keep it there. Now that we've got this sort of liquid thing going on, let's just create the other word. So I'm going to just kind of copy this setup. I'm going to literally select all the nodes, like so. I'm just going to copy this setup. I'm going to select all these nodes, hold down the Alt or Option key, and just drag them off to the side. And we'll call this input or object B. And I'm just going to change this text to morph. So I've got my liquid and I've got my morph. Cool. So now to set up the suction fluid, let's just use this second object right here, just to, kind of get things rolling in the flip sim. So I'm going to go up to the suction fluid shelf tool up here in particle fluid. So in case you weren't on the particle fluids shelf, you don't want to be in there. And we're going to choose suction fluid. And it's looking for us to select objects for suction fluid. So I'm going to go up here into my object level. I'm going to select the target. Then I'm going to put my mouse back over the viewport and hit enter. Now this tip down here is asking for us to select the flip fluid to apply the suction to. So I'm just going to select this flip fluid now over here, and put my mouse back over the viewport and hit enter. I find that having the mouse over the viewport when we are hitting enter after making these selections tends to get the shelf tool working right. Sometimes it can error out if you don't do that. So now over here, our flip sim has added a couple nodes for us. And one of them is anti-gravity, which it will apply to negate the forces of gravity within the region of this suction force. And then the other one is the actual suction force itself. And you can see there's a couple options on here, which is the inside and outside distance and then suction strength. So all of these values can be tweaked to kind of control how far outside of the suction object the force reaches to pull it inward, and then sort of about how it kind of behaves once it's inside the surface. Then again, also the strength of the suction itself. So now that that's been applied here, if I go back to this flip fluid object, and well, now you can see the flip fluid object is actually set to morph. What's up with that? Let's just look at our initial data on the flip fluid object. It's actually looking up this SOP path, and we went over this in the previous example, but sometimes using the shelf tools will cause it to look up a SOP path that's actually on the object level, which means that whatever node is actually visible inside of this network is what's going to be, visible here. So I could simply change this to be only looking at the font of this first liquid and just jump back over to my fluid sim, and it's disappeared because there isn't enough volume to compute whatever's going on. But if I switch to object A or object B, now it is displaying those particles in our network. I want to be a little bit more specific about it to avoid that kind of thing from happening. So we're going to use object A, this null, as our input instead of the object target. So we're going to just drag this in here. And that just basically instead of just looking at the target object, it looks at the target object, then looks inside for object A. So no matter what node I have selected in here, if I select a node in our flip sim over here, you can see that no matter what I do, it's always displaying that liquid, which is good. So the other thing that shelf tool did for us when we added the suction force was it added this little suction target after our object B. And that suction target basically is going to create a volume and compute a velocity based off of the incoming geometry. And that's more or less created for us a VDB that will act as the suction target. So if we go back over to the flip fluid object, we have the word liquid here, and we have the word morph as our suction target. If we click play, you can see that the liquid kind of falls down a little bit, and some of the liquid moves towards forming the letters morph. So let's see if we can mess with some of these values to get it to kind of adhere a little bit better. What I'm going to do is increase the outside distance to something like maybe 2, and I'll do inside distance of 1. Basically, that's just looking further outside of the object to find particles that it will be sucking in. Let's click play. Results are a little bit better, but it's generally still not strong enough to hold on to most of these particles. So let's just increase the suction strength a little bit. Let's bring it up to something like 40,000 and see what we get. You can see that not so many particles are falling down. Some of them are, which we want, but many of them are actually starting to stay up here a little bit better. Still want to kind of increase this a little bit higher. So let's maybe go up by a factor of 10 and see what that gets us. 400,000. And click play. And you can see really no particles are falling away, and they are seeking that morph, that target morph shape quite quickly, which is cool. So click play on that. You can see that it's wobbling around and reaching that goal relatively quickly. Now, when we do ours, we're going to want to have some sloshing around and a little bit more interesting behavior than this. And a lot of that will come from sort of when we apply we're going to actually apply some shifting suction target that actually will kind of push around these particles as it sweeps through the geometry from left to right. And also increasing the resolution will cause this to look a little bit sloshier as well. But for right now, I mean, really, that's just the basics of that setup. You can do stuff inside this anti-gravity node, which is counteracting our gravity just fine right now. But you could also apply different drag force strengths to try to get it to slow down. If you notice towards the end of this sim, it's wobbling around quite a bit. like in here. If you wanted to increase the drag force strength at that point, it would generally have like a much less active result in the end. So now if I come back here and click play, you can see that once it gets into its final shape, it kind of doesn't jiggle quite as much. So those are some cool settings with the anti-gravity and suction force nodes that were created over here to kind of control the situation. So now what I want to do is actually modify what actually is being used as our suction target. So if we look over here, the anti-gravity is looking at this volume and velocity node that was created, these nodes that were created down here. So really anything we do leading into this is always going to be looked up by these by this node. And same over here, it's also looking at this target volume as well. So we can just do a whole bunch of work right in here, and it'll cause us to have an ever more cool looking suction target, and therefore ever more cool looking simulation. So let's do some stuff. To get a cool morphing effect, what I want to do is actually scatter points inside each one of these objects. Since I can't just do a morph between the two of them using the topology that we have, I could scatter points inside and then actually do kind of a pose morph with those points. If I had the same number of points within each piece of text, I could then sort of transition them from one to another smoothly. So let's do that. I'm going to throw down first off, I want to just disable simulation for right now by hitting the brain down here until I get that little Ghostbusters symbol. And then I'm going to also go up here and say hide other objects, because I just want to focus in here on our liquid morph thing. So right here, let's throw it on a VDB from polygons. And I want this to, if I wire this in here, it's a little bit low res. I'm just going to bring the voxel size down by a factor of down to 0.01. So I get a surface that looks like this right now. I'm going to actually not use a distance VDB or assign distance field or whatever. I want to actually use a fog VDB. So now you can see that it's sort of this fog voxelized thing that we can scatter points within. So let's throw on a scatter now. And we can scatter a whole bunch of points that will be within this volume and filling in this space. But we don't have nearly enough points for it to work. If we were to kind of convert this back into a surface in the end, which we're going to be doing with a VDB from particles. If I were to wire this in here and choose to bring this voxel size down a little bit and maybe bring the point radius scale down to 0.01, to 0.1 or 0.01. Maybe a little bit bigger than that. That won't work. Yeah. So if I were to bring it, this isn't enough resolution. It's not filling in our volume. We're going to have to bring this up, and then we just actually don't have enough resolution to even see the word liquid. So we're going to increase the number of scatter points quite a bit. I'm just going to delete this VDB from particles temporarily, and I think that a value that works good is something maybe like 50,000. So if we scatter 50,000 points throughout this liquid, we get a nice dense shape like that. It takes a little while to calculate, and you can see that it kind of has these interesting outlines, and that's because it's using this point relaxation down here. I don't want to do any of that, so I'm going to just turn off relax iteration. So it's just a more truly random distribution. And I'm also noticing that my camera clipping plane is kind of cutting these particles off a little bit further away than I really want to. So I'm going to hit the D key, and I'm going to go to the view. And here I'm going to choose under clipping where it says near and far clip planes. I'm going to just choose neither clip plane. Basically that this is the homing auto adjust. We want to adjust neither clip plane, and then I can set it manually here. I'm going to set the near to 0.01 and the far to 10, or no, maybe 100. Just so that we're in that range where we can get really tight on our particles. So the next thing I want to do is create a sort of an attribute that we can send through this that will allow us to change these points positions. So I'm going to do that using an attribute transfer and an attribute create. So we're going to create an attribute, and we're going to call it morph right here. So it's going to be morph, and it's going to be a float attribute, and on the actual geometry initially, it's going to be a value of 0, which is good. And then the thing we want to do is actually transfer attributes from some other object onto this object. So we're going to create a grid, and I'll just orient the grid along the YZ plane and just move that grid off to the side. I'm going to hit spacebar 3 so I get a frontal view. And I'm just going to bring the size of my grid down a little bit. Something like that should work. Size of maybe 1.7 is good. And then I'm just going to kind of keep the grid off to, I'm going to push the grid off into the negative X direction we'll move it over by like -2. It seems good. And so the attributes we've got here, having a grid like this is going to make it like a nice linear fall off. If I did a point and transferred it, it would kind of arc at the beginning, and I just kind of want to have this generally be like a nice linear fall off, and having a bunch of points over here distributed like a grid will allow us to do that. So I'm just going to option or alt drag this morph attribute and apply it to our grid, except I'm going to set it to a value of 1. And if I go down here and throw down a attribute transfer, and we're going to wire in our liquid particles in the left and the grid into the right, and click and set the display flag to the attribute transfer. Nothing's really noticeable at this point, but I'm going to throw down a visualize, and then we can see that attribute in action. So let's wire this in here. Default visualizer is just visualizing the position, and we want to actually visualize morph. So morph is now just mapped to the color red, and you can see that it's taking over the entire text, the entire liquid text. And that's just because we need to set up our attribute transfer. So let's go and turn off primitives. We're only going to be dealing with transferring point attributes, and we'll transfer the morph attribute. Still on the visualizer, everything's red. That's because under conditions, the distance threshold is set to be too high. So if I bring that down, you can see that we're able to actually sweep that distance threshold across our text. And here we could actually even set a blend threshold, or blend width, so that it actually gradually transitions across the text. I'd say now what I'd want to do is, it looks like our distance threshold, what we can do is we can animate this distance threshold to get it to reveal and change the positions of these particles so that they land in a new position where the morph particles will be when we create them. So let's do a little bit of animation on this. I'm going to bring this back so that all of our morphs in our geometry spreadsheet are set to 0. So I'm just going to go up and down. I'm basically sorting these columns to make sure everything's set to 0. Because even though I visually can tell that everything's black, sometimes values creep in there that you weren't expecting. So with the value of negative 0.9. Well, I actually want to make sure my blend width is long enough. We'll do a unit of 2 for our blend width, and then I'm going to just drag the distance threshold back until everything becomes black. And just checking my geometry spreadsheet. So we're good at about negative 1.75 for this example. I'm going to hit Alt and hold Alt and click on the field to set a key, and then we'll go out to frame 120 and crank this up like that, and hold Alt and click and set another key. So now we grab our timeline. We got this going on, which is cool. Let's set up our morph. What I want to actually morph to, though, I need an actual target. So what we're going to do is actually create, do the same thing that we did right here, where we created a density and a scatter. and we're going to apply that to object B. So I'm going to just actually disconnect the suction target for right now, and then I'll rewire it in later. But we've got our suction stuff down here when we need it. So I'm going to actually create a reference copy of this VDB from polygons and this scatter. And that basically will make it so that whatever settings I set for resolution and density and scatter count over here is going to apply over here. So let's right click, actions, and create a reference copy. And you can see if I click on one of these, all these fields have this kind of blue highlight to them, meaning that they're being controlled by these nodes over here. If we go to show dependency links for all nodes, you can see these arrows are pointing off to the right, showing that these nodes over here are actually controlling these nodes on the right, which is kind of handy to have sometimes. But I'm just going to turn that back off. Say hide, and I'm going to actually wire in object B now, like this. So we have sort of the same thing happening over here, but on this node, we don't actually need to do another attribute transfer. What we're actually going to do is use a point vop to look up these point positions and then adjust the positions of our original points based off of this attribute that we have right here. So let's do that. I'm going to throw down a point vop. And this is going to be our, we're just going to make our own sort of pose morpher right now. So in the first input, I'm wiring in right after our attribute transfer. And then in our second input, I'm bringing in what we just did over here with our scatter. So let's just dive inside the point vop, and I'm going to go and set my right view to be sort of up where we were above. So I've got my point vop on the right that we are editing, and the actual inside of that point vop on the left-hand side over here. So to the first thing we need to do is we need to access the point positions of this second input. To do that, we're going to use import point attribute. So let's throw that down, and what it's looking for is a file, and we want to use op input 2 since it's the second input coming in right here. So if we wire in that here, it's looking that up from the second input. And because input up here is set to file, everything's good. We could actually, change this and set it to first manually read those, but I just like having it connected because it actually gives sort of a visual representation of what we're doing down here. And so the position, the attribute we want to look up actually is position, which is cool. And so now we could just do a mix. So if I mix our current position that we have on our geometry already with the position that we are getting from this other attribute and wire that out, we get this sort of, it looks messed up because we've got this bias here. So this is basically a blend shape. If you had consistent topology and you're using this, it would literally do a blend shape for you. You've sort of just set up your own blend shape from scratch using VOPs. So we've basically created our blend shape here, but it is not looking too pretty. We've got this sort of grid-like behavior as it's being broken apart, and everything's happening all at once. It's very linear, and we've got points from the left moving all the way over to points on the right and vice versa. And really, we just kind of want to keep this, we want this to look nicer. We want points that are near the left-hand side of the word to adhere to points that are on the left-hand side of the word and the right-hand side of the word, and so on throughout the entire thing. So what it really has to do with is the fact that when we're looking up the point on the second input here, that point could exist anywhere. These are two, even though these two random scatters are seated the same, they're actually scattering over a completely different geometry, so they're going to have a completely different distribution. And so the point numbers are not going to really line up as you would hope they would in space. And the way we can get around that is by actually sorting them. So what I could do is throw down a sort node. And if I sort on the left-hand side, I'm just going to put that sort down right before the scatter. And I'm going to say I want to sort the points in X. So lower numbered points are going to be on the left-hand side, and higher numbered points are going to be on the right. And you can see that that has already changed how this morph is behaving. You you can see that it's all kind of moving into the center and then coming back out on the other side. We've sorted these points on the left hand side. We also need to sort the points on the right input as well. So we need to sort our morph points. So let's just I'm going to option drag or alt drag the sort out and just wire it in after the other scatter. In fact, I'm not going to do that. Let's delete that. I'm going to actually do another reference copy since we've got reference copies over here. So we're just going to right click actions, create a reference copy, and I'll just wire that into the second one. So both of these are being sorted along the x-axis, having the points sorted along the x-axis. So now when I move this, you can see this isn't necessarily that much greater. We still do have this kind of breakup because there's more letters in the word liquid than there is in the word morph. You kind of get these vertical slices that go through the letters, which we don't really want, but we can do some more stuff to kind of hide this. What I do like about what I'm seeing is, for example, if we look at the top of the L here, or the L in general, a lot of the L is going to a position that is similar on the M. We don't have points that are flying all the way to the other side of the geometry to meet up with their partner. They're more or less staying horizontally in the same space, which is good. That's what the sort does for us. So the next thing that we could do to kind of make this look a little bit cooler is we could use that attribute to drive. Instead of this bias here that we're sliding that kind of blends everything uniformly, we can actually drive this with an attribute. So if we look over here on our mix node, it actually has an input. And this is a lot like a mix material if you're doing something with a shader, except now we can use our attributes as a shader for the geometry's position in space. And really, this is sort of like we can feed in an alpha channel for what the effect of this mix is going to have on our particles. And the way we do that is by using a bind import. So I'm going to throw down a bind, and I'm just going to wire this into the bias, and you can see everything jumps back to 0 because there's nothing going on, but I'm going to throw in our morph attribute that we created. And now if I scrub through the timeline, you can see that morph is gradually happening from left to right. It's still not super pretty how we have got this these areas that are broken up here, but it's starting to get better, which is cool. Another thing that I want to do just while I'm here to make sure everything is just for the sake of completeness, if I go down here, my import point is actually looking up a value in the second input based off of it. It wants to be looking it up based off of what the current point number we're on. So I'm just going to wire this one in. It seems like it was able to keep up on its own, but I'm just going to wire that in there in case because I think that it's hoping to get it and it's defaulting to it, but I don't 100% trust it, and I want to be explicit and make sure that I've got all my stuff hooked up the way I'm supposed to. Cool. So now that we've got this sort of morphing behavior working out for us, I want to add maybe some noise to the to this attribute that we're transferring. So if we go back up here to our visualize and we just play it back, we just have a linear gradient going from left to right. But what if we added some noise in there to kind of chew it up? That would actually make it look like it wasn't not like all these particles were leaving at different times to reach their final destination. So we could do that by creating another VOP here and using it to kind of noise up this morph attribute that we created back up here. So I'm just going to name the VOP that we're currently on, and I'm going to name this the morph. And then we're just going to create another point VOP and use it to do some modifications to this morph attribute that we have. Just going to wire the visualization up to this node and call this noise. I'll call it attribute noise. And what I'll do is I'm just going to drag it to the left here and then dive inside. So now I'm inside the attribute noise VOP, and we can start messing around with this. So what I want to do is bind in first off the morph attribute. So we're going to bind again and set this to morph. So we're binding in the morph attribute, and then maybe what we want to do is actually add noise to it. So let's throw down a turbulent noise. Now, if I just wire this noise out, we're going to have to export the attribute as well. So I'm going to throw down a bind export like this and bind out the morph attribute. You can see that it's created this sort of noisy pattern for us, and I can modify the frequency of that noise, and that all shows up nicely. One of the things that I would like to do is sort of obviously I only want the noise to happen during where our attribute is transitioning. I want our attribute to actually be fully activated where it's red and fully deactivated where it's black, but I would like the noise to occur in the middle here, and we can actually remap the value of the noise to be maximum at 50% by just using a ramp. So if I throw down a ramp here, not that, we're on a ramp parameter. We can remap the value of the morph attribute if we set this to a spline ramp here. And then over here, if I select our attribute noise, and let's just wire the visualizer back in here, I can modify this ramp. I'm just going to wire the ramp into the morph output. You can see that the ramp is by default set to 0 and 0 on either end. I'm just going to add a notch in the middle and set it to 50%, so 0.5, and then give it a value of 1. And now you can see that instead of having that value kind of be masked on, we only have a mask that is during the transition of it going from off to on. So we're sort of like doing a little bit of composite work here. We're more or less building a mask, and then we're going to use that to only apply the noise in this region. So if I were to multiply our noise that we're creating down here by this ramp and then wire that out, you can see that we get noise that is confined to this area. So the next thing that I would like to do is just sort of, I guess, kind of multiply the original morph attribute by this noise. So let's just throw down, let's just throw this morph attribute in here as well. And that's not going to actually work because we've got, because this is a multiply and it does go to 0 on the left. I'm actually going to do something different. Let's just unwire this here, and I'm going to actually subtract whatever noise we've created here from our original morph. So let's just bring this up a little bit, and I'll just throw down a subtract. Just wire the morph in here and bring this the results of this multiply in here, and then wire that out. And then you can see that we're starting to get this sort of noisy fall off effect happening here. Now I want to do some adjustments on the noise. I don't want to use an alligator noise. I might use sparse convolution noise. And the other thing I want to do is sort of evaluate what the range of this noise is. So I could maybe I'm just going to bypass and just check and see what the range is right here. If I look at my morph attribute and sort my morph attribute, now that I've set this, now I've just bypassed this turbulent noise directly into it. I can use this attribute to kind of debug what the range is. So it looks like I've got noise ranging from about negative 0.5 up to 0.8. So I'm just going to fit range this real quick. So it goes closer to between a value of 0 and 1. So if I run this fit range through here, set the source minimum to negative 0.5 and then the maximum to 0.8, it should remap from 0 to 1. And so if I look at my morph now, I've got values of 1 at the bottom and values of 0 at the top. So that's good. So now I'll maybe just send this through our multiply right here, and then we'll rewire our subtract back out to the morph. And so now we're starting to see that sort of subtraction happening here. Now let's check our morph. I don't want any values to dip below 0, and it doesn't look like they necessarily are right now, but just to make sure, because we are kind of just doing these unbounded like subtraction, I'm just going to throw it on a clamp. And the clamp basically will allow me to specify two values that the output won't exceed this minimum and maximum. So in case any values do go above 1 or below 1 because we're doing this subtraction operation here, it will keep those clamped. So now that we've done this, if I just move this across, you can see that noise pattern is kind of moving through and being adjusted, sort of existing along with the gradient, which is looking cool. I think that I might want to adjust this later, so I'm going to just go to my turbulent noise, right click on it, and say Vex VOP options and create input parameters, and that adds parameters up to our attribute noise VOP over here so that we can kind of modify all this stuff up in SOPs. So what I might do at this point is I could probably modify the frequency. It looks a little bit low frequency. I'm just going to bring it up a little bit, something like maybe 4 or 5, and then maybe I could modify this curve if I felt like it wasn't, if it didn't look right. But for right now, I think that that's pretty good. And let's just see what impact it has had on what our morph looks like now. So I'm just going to go highlight the morph and play this back a little bit. It's starting to look pretty cool. You can see that different sections are starting to morph at different times, and it's getting better and better as we go. I mean, we still have this kind of awkward crossing going on right here, which I'm not too huge of a fan of, but I think that it's starting to look better. So look, I think at this point, the next thing that I'd want to do is actually maybe add a little bit of noise to the transition as well, so that the particles don't just linearly transition to their next position, but they actually inherit a little bit of like a noise offset while they're moving from point A to point B. So we can do that by doing something similar inside of our morph here, where we're actually controlling positions. Up here, we're controlling sort of our morph value that is driving this morph. So we're using the morph attribute to drive the morph VOP, which is changing the position. So we can actually use that to we can actually create an offset for position inside of here as well. So let's do that. Just want to get in here and create some additional noise so that we can mess around with the positions of these points as they're doing their transition. What I need is a noise, so let's do another turbulent noise. And I'll bind in the position. We'll also use sparse convolution up here. And this noise is actually going to be a three-dimensional noise because we're going to be modifying positions, which are vectors in space. So we've got our noise, and if I just wire that into position just to see it real quick, you can see that it's creating this, this noise pattern. What we're ultimately going to want to do is add it to the position, though. We want our original position to be where it is, but then we want to add to it this noise. So now, I don't want to add velocity. So I'm adding position in. You can see that this noise function is moving the positions of those pieces all around. I just want to double check the range of this turbulent noise. So I'm going to just, I'm going to just wire the range, the turbulent noise into the color real quick, and then look at the attributes over here. So I'm seeing that we are going from, let's just sort by, if I just click the tops of these columns, I'm going to sort by the red color. Looks like it's going from negative 0.5 to positive 0.6. Let's try simplex noise, see what we get there. This looks a little bit cooler. And let's see what range we're getting for that one. So we're getting this simplex noise going from negative 0.15 up to 0.15. I'm going to actually just increase maybe the frequency of this noise a little bit so I get a better range over here. So it looks like it's more kind of just randomly distributed. And by kind of clicking a couple of these and going back and forth, it kind of will start to snap into position. it looks like I'm getting a value of negative 0.28 up to 0.25. So I'll just use a fit range to map this turbulent noise to those values. So let's put down a fit, and I'm going to put that in right here. So our noise is going into the fit, and I want the minimum to be, what was it? I think it was negative 0.28. So source min is, let's just do negative 0.25, negative 0.25, negative 0.25, because this is a vector. We have to do it for all three values of x, y, and z. And then the source max is going to be 0.25, 0.25, and 0.25. Like this. And then we want to remap that not from a value of 0 to 1, but from a value of negative 1 to 1. So I just put negative ones there. And this makes it a little bit easier for me to understand. So now what I could do is I could just add my own little multiplier parameter to kind of control what the value of this is. And I'll just do that right here. So let's throw it on a multiply. And we just need to add a parameter. So I'll throw down a parameter, and this will be our multiplier parameter. So let's just wire that into the multiply here and call this multiplier. Cool. So I've got, this is funny, I've got my other VOP on the left. I'm going to actually just jump up here and look at our morph. And you can see we've got our multiplier here. And the more I crank this up, the more it moves all these particles for this liquid transition. So that's cool. But we are currently, I no longer need to, I was only looking at color for debugging purposes. Don't need that anymore. And the other thing is I don't want to be applying this noise for the entire transition, or for the entire time. I just want it to occur during the transition, like how we did right here. We just created a curve to kind of mask off the effect of that noise we added to our attributes there. So let's throw down another ramp parameter, and I'm going to feed into it the morph attribute itself again, and it's going to be a spline ramp, and that's now appearing over here. And I can just do the same thing and just add a value at about 0.5 that kind of makes it so that this noise is really only going to happen in the middle of this transition. And I just need to multiply this now as well. So we have this multiply, Control B. We have this multiply that we're using over here to multiply the effect of our noise. So here's our noise. We're going to multiply it to control the effect of that noise. We can also just add in another multiplier here and just multiply it by a third thing, which is going to be that ramp parameter. So if I Control B to go back, you can see that now that that ramp is kind of controlling where it's happening. Before we had it just doing everything, but now we're sort of able to mask it off in the middle of this transition and get that effect to sort of kind of noise up that movement a little bit more. So on this last one, I'm having a hard time grabbing that last knot, so I can just go down here and select the knot and then bring this value back down. And I'll just set this so that in the middle it kind of reaches its maximum noise amount. Ultimately, this noise, we're just adding it to the initial position of our geometry. We're going to want to actually add it to what's happening to our mix down here. So I'm actually going to just take this position that we were using to kind of determine it initially and just wire that into the mix. So now when we move our liquid across, or as we move our time slider across, we're getting this sort of noise-like effect as it pops out and reaches its final target. I would do the same thing here that I did before, which is right-click on the turbulent noise and under VexVop options say create input parameters. So now I can go up here onto our morph. I can mess with this multiplier and have it get a little bit crazy if I want. Stuff like that. this in of itself is kind of a cool effect. I mean, if I was just trying to do a particle transition, I would probably tweak some things, make it a little bit different, but make it a little bit smoother. But because this is going to ultimately just be a suction target for something that is simulated and looking cool pretty much no matter what you do, I'm not going to push this too much further than this, other than doing a couple other things after the fact. So we've got this sort of disintegration, reintegration effect happening, which is really fun. And what we want to do now is turn this thing back into our field that we can use to act as a suction target. So I'm going to create another node here called points from volume. VDB from particles. And we'll just wire this in here. And now our particles are huge spheres at this point because there isn't really a p-scale attribute that we assigned. It's just kind of making the point radius be one world unit, not what we're after. So I'm going to bring the point radius scale down quite a bit. Let's bring this down to... And now once you get below a certain level, there isn't enough voxel resolution to represent it. So I got to bring the voxel size down to 0.01. And thinking about it, and I'm just going to bring this down further and further. And it looks like if we go even further, yeah, like a value of 0.02. Let's try that. Now this looks very particle-y still, but if we were to apply VDB smooth SDF, we would see that we are starting to get something that looks like our liquid. We're not like trying to make this look like a liquid per se, but just to get something kind of vague that we could have a suction force adhere to. This is starting to get there. So if I scrub, you can see like it looks like the liquid disintegrates. It looks to me like the liquid's actually disintegrating a little bit too much. I want to make this transition a little bit more coherent than this. So I think what I'm going to do is just kind of revisit this morph and mess around with this multiplier a little bit to see if I can get these particles to kind of stick together a little bit more. And maybe I'll mess around with the frequency as well. I think it might be a little bit too high frequency. I just want to bring it down a little bit to maybe something like 6. Yeah, now we can see that everything's sort of staying in the right area. Look at that. I might bring the roughness down as well. So let's bring the roughness down like that, about a value of 0.2. Yeah, I think that that's looking pretty cool right now. If I check it out after we do the smoothing, I might just modify the smoothing settings a little bit. So here we're getting kind of a lumpy surface, but if I were to change the filter voxel radius to go up a little bit more, that brings us something that's even smoother. And I can maybe just bring these iterations down. You can see how that's having an effect on it. Maybe I'll just leave the smoothing iterations to something like 3. So now when I kind of scrub through the timeline, we're getting this sort of morphing that's occurring and changing our text as we go from left to right. And you could almost actually just export this as an effect itself. It kind of looks pretty cool. But again, this is really only our target that we're going to be adhering to using the suction force. But it does have sort of a cool look to it in itself. I think the next thing that I would like to do that I thought was fun is that I felt when I was doing this that it felt like it should twist as well. So what I want to do is actually have a bender move through here and twist this thing as it's doing its transition. So we're going to have that happen before we actually do this VDB stuff. So right after our morph, I want to add a bend. And even though it's called bend, the bend is the node that has our twisting controls on it. So let's just wire the bend in here and highlight it. And what I'm going to want to do is actually change the orientation of the bend. Maybe I'll just add a little bit of bend to it so we can see that it's working. So just going to set an angle of like 50, and I'm going to go down here to the capture direction, and we want it to capture in X. So I'm going to set this value to 100 down here in the capture direction. And then we don't actually want it to bend at all, so I'm going to turn that back down to 0, and then we're going to mess around with the twist. And I'm going to want this twist value to be a value of 180, because as we move this through, we want our word to do a flip as it transitions, just to add something a little extra. And it would be great if this actual bend was occurring in tandem with wherever our attribute transfer was. So I can do that because we've got this capture origin right here. And this capture origin is more or less being determined by whatever position I put this in. So since I have this capture origin and I know that I'm doing this attribute transfer, and that the attribute transfer is transferring this distance from this grid, I could use a couple little tricky expressions to get this bend or origin to adhere to that position. So the first thing I need is the position of the grid. And so if I look over here, I've got my grid center, which is set to -2. I can just right click and copy this parameter and go over to my bender and paste it in here. So paste relative reference and hit enter. Delete any extra characters that are showing up. Don't need those. And the next thing I want to do is we actually have, right now it's not 100% lined up. We've got our attribute transfer over here, which is actually set to a distance of -1.76, and then this is what's actually animating. So if I copy this parameter as well and add it to what we put in here in the capture origin, so just I'm going to put a plus sign in there and then right click and say paste relative references, it actually moves our bender way out here. And then if I scrub the timeline, you can see the bender's moving along and doing the twist pretty much along with whatever's going on with the with that morph that we were doing. So other things that I want to mess around with was the how we've got this blend width. Our blend width I want to match up to our capture length. Our capture length just determines how long of a twist we're going to be doing. So our blend width is 2. I'm going to set this capture length to 2. And if I really wanted to be robust about this, I could copy this parameter and paste relative reference here as well. So if I change the blend width, it actually changes not only like how much noise is happening on the particles, but it's also rigged to update the length of the bend that we're doing. So I'm just going to set this back to 2 where I had it. Now when we play back, we get this sort of cool effect. But the problem is that we start with the liquid being upside down, which isn't necessarily a problem. We can just go up here to our original font. Now we're going to be inputting this as our initial particles for the fluid sim. So I'm going to put in a transform afterwards to rotate it back 180 degrees in X. So right here, I'm going to throw in a transform, and I'm going to wire this in, and then I'm going to flip this 180 degrees in X. So now we have an upside down liquid, but once we get to this bend part right here, liquid is now right side up, and it flips upside down and turns into morph. And so we can really see what's going on. Let's go back to this VDB smooth and play this down now. So we can see the liquid is right side up, and then eventually it starts to twist and flip upside down and morph at the same time into our new morphing target. So I think that this is going to work for our liquid morph now. I mean, we're getting pretty close to having what we need. So let's just see what our sim looks like and wire this thing into our suction target now. So if I hop back over here to the auto.network, put the auto.network in one of your things here, and let's just go back to frame 0. Now we had turned this brain off so that we didn't have to think about it anymore. So I'm going to just, so that this wouldn't actually accidentally start calculating or anything like that. So I'm just going to turn it back on so we can run some sims and see where we're at. So I'm going to click play. It's running pretty slow for right now. Increase the particle separation so that we can just run this a little bit faster and get some feedback. Additionally, what I'd like to do to kind of speed things up is I want to cache out this whole thing that we did here. We've got all these, we've got this particle morph thing, and then it's going into this VDB from particles, and I just want to just sort of cache, put in a file cache right here at this point so that we can take that out of the equation here. So let's throw down a file cache. And we're going to just cache the first 120 frames of this. So I'm just going to drag these down. And I'm going to call the file cache, what are we going to call it? Let's call it the target cache. And then up here, I'm going to right click and on the end frame and say delete channels and just lock this into frame 120, since that's the basis of where our animation is actually occurring. Then up here, I'm going to just rename the file path to go into a cached folder, and then another folder named after the operator, which is target cache, and then another folder named after the file name or hip name, and then it'll create files based off of that information as well inside of there. So now that we have that, I'm just going to cache this out real quick by clicking Save to Disk.